Okay, there it is. All right, so that's opposite. That is hypotenuse, and that is adjacent. So tan theta is equal to opposite over adjacent. And so we have 22 over adjacent, which is 2 square root 23. So I didn't need that part. And so then you would have to reduce. I see that these reduce, and you get 11 over square root 23. I'm going to multiply the top and bottom by square root of 23, and you get 23 in the denominator, and you get 11 square root 23. So that's what I'm getting. And what does the solution say? So for Unit 5 Lesson 2, I uploaded the second part of the video last night. So you probably didn't see yet. So maybe after the session, watch the video. So for number 8, does that make sense? I also have 2 other questions. How do you find equivalent expressions for a trig ratio? And how do you find the coterminal angles? So for example, if I have my coterminal angles, the easiest way to find it is if you rotate that, you're like on a Ferris wheel and you rotate it 360 degrees. That means you're at, so another angle that you can say, if this is theta 1, you could say theta 2 is 360 plus 30, which is 390. So that's a coterminal angle. And then theta, another theta I could have said that was a coterminal angle is doing 30 degrees minus 360 degrees. Okay, perfect. So yeah, my theta 3 is going to be 30 degrees minus 360, and that's negative 330. So the easiest way to find coterminal angle is to add or subtract 360. So that's how you find the coterminal angles. Okay, that's number 8. Should we go on to number 29 for now? How do you find the equivalent expressions for trig ratios? Okay, so with this 30-degree example, if I said, so if you were asked to find sine of 30 degrees for the example above, so I'm just going to copy and paste this to the other page. And so if the question was, if this was the principal angle, right, and you have sine of 30 degrees, and they asked you the trig equivalent ratios of sine 30 degrees, if that was a question, I'm going to write cast, because I write that every single time. So let's see, sine 30, I know that it is positive for sine over here and over here. And so let's see, I have sine 30 degrees is equal to, and underneath, just to double check, I should be getting 0.5 as my value. So my related acute angle in this case is, so that means my related acute angle is 30 degrees. And so what I'm going to do is start drawing a couple things. So that's my related acute angle. And so I could draw another angle that will give me that same value of 0.5. And let me try it. So if I draw a line here, and I also make this 30 degrees, then both these angles will have a corresponding related acute of 30 degrees. Well, for me to have a 30 degrees there, that means, well, this is going to be 180 minus 30. So that is 150 degrees. So let me try it. So I'm going to predict that my other first equivalent ratio is sine 150 degrees. And that's how I got it. Let me check. Yay, and I get 0.5. Okay. And this is all coming from that cast, sorry, over here, this fancy part over here, where as long as you're dealing with the same related acute angle, you're getting the same value every time. And it's just a matter of the sign that you're looking at. Okay, so does me getting, do you get how I got sine 150 degrees? I had to start use related acute angle to find the equivalent trig ratios. Let me write that down. So I had use, yeah, okay. No, I already wrote there. So over there, use related acute angle to find. Okay, so what's another one? Think you can predict another one? How about I'm gonna draw you a line and let's see if you can find it. If this is my angle that I drew, and that means this is 30, what is the trig ratio that's gonna make this work? Sine of what? So you can kind of think of it in your head for a second, because I know it's hard to like spit the right answer right away. My thinking process is this. I have 180 degrees from here to there. That's 180 degrees. That means I have to do 180 plus 30, right? Do you see that? And so then it's going to be, let's see, blue. So that's going to be 180 plus 30. And that's equal to 210. And so I'm going to write sine 210. And can you tell what I need to do after I write that? Do you think I can leave it like that? Or do I need to do something else to it? What do you think? How would I make these equivalent ratios? What do I need to do with sine 210? Okay, that's fine. I have to put a negative there because if I, on my calculator, I do sine 210, I get negative 0.5. Yeah, so I have to put the negative 0.5 to see how it's not part of my highlight. Like these are positive, but it's negative over here. So as soon as you're making these angles where it's not positive, it's not the same sign, it's like, yeah, you can still make it work, but you have to put the negative. Yeah, so that's the part. So I'll do one more example just to hit it home. So if I draw another angle over here, and the related acute angle is 30 degrees, and that means that angle is 360 minus 30, which is 330 degrees. It's really messy. I have to fix it up. That's sine of 330 degrees, and that means what do I have to do in front of sine 330? I have to. Yeah, exactly. Is it making sense? And then I'll just check on my calculator. Negative sine 210. I'm getting 0.5. I'm getting 0.5. Yeah, and everything's working. So I gave three equivalent ratios of sine 30. And I'll just clean this up and I can add it on. So is that all for your questions? Okay. Okay, perfect. Or I'll see you later. I'm gonna go see my grade 9s now. Okay, bye.